don't like bad graphics. So, that's what engineers do. They see things that they like or things they don't like, and they ask why or why not. So, I'm going to give you a broad range of examples. I'm going to like jump generations in technology just for fun. So, is this one? No. I'll just use my hand now. All right, so anybody know what this is? So this is, oh, I didn't know what this is. It's a fountain pen. So apparently a really long time ago, you used to have to hold this thing and dip it into ink to write, which is ridiculous. Some old guy said, this is ridiculous. I want to hold the ink inside my pen. So he eventually invented a ballpoint pen. I don't know his name, he's not that important, but we appreciate it. Ford, long time ago made a car, I think it was called Model T. I don't know when that was either because that's older than me. But some guy, Elon Musk, said, hey, why should our cars use gas? Let's make them electric. So he makes all these fancy electric cars that cost us entirely too much money. Everybody's familiar with cell phones. I think since you all have been alive, cell phones have been in existence. But they used to be really not great. And now, iPhone 7, they're a little bit better. And sometimes we ask why not. So there's a company called Avigant, and they said, hey, why can't I just have a theater on my face? I don't want to have a big TV. I don't want to have to go places. When I'm on a plane, I don't want to look at other people. I just want awesome speakers and movies projected directly into my eyes. So that's what engineers do. They ask why or why not. And then they hopefully create the things that allow those things to come to being. So a little bit about me. Oh, excuse me. I'm going to go back before me. So there are a lot of places where you can be engineers. I mean, everybody's heard of NASA. There's aerospace engineering. They send people to the moon. They send rockets to space. There's satellites up there. Cars, electrical engineering, which I am an electrical engineer. Computers, I heard computers before. Environmental engineering, how do we take care of the things we have? How do we keep this world safe? So tons of areas of engineering. Anything you like, there's probably a form of engineering that can impact it in general. So a little bit about me. My name is Terrell Bennett. I have a PhD in electrical engineering. What does that mean? That means I stayed in school a really long time. What else does it mean? It means I get to be fancy and make people call me doctor if I want to be. So it's like, you can call me Terrell, I'm fine with that, but if you want to call me something else, Dr. Bennett is the right answer. That's okay too. But Terrell is fine for today. So, a little bit about me, I'm from Chicago. I should ask a question. That's kind of a Chicago state flag, or city flag mixed in with the skyline is awesome. When I was in high school, 16, 17, 18, like you guys, things I like to do. Math, play saxophone, like my friend here, video games. Any video game I like. And actually video games drove a lot of why I wanted to be electrical engineering, because I said, I like these games, but some of them suck. How can I make them better? Unfortunately, I don't make games today, but that was my thought process. Can I say something? Yeah. Meant to check that before we started. But that's the thought process. So from there, I went to a small school in the Northeast called MIT. Anybody ever heard of that school? Anybody want to go there? Great idea. You should all go there. Great school. After that, I worked in different places. Motorola, company that used to be a little bit more popular, made cell phone stuff. Spent some time at Texas Instruments. Since then, I've done, again, my master's and my PhD at the University of Texas at Dallas, which is about 30 minutes from here. And I currently am the Chief Technology Officer at a startup that makes children's wearable products for safety. So that's a lot about me. But you're here not to learn about me, you're here to learn a little bit more about engineering and IT. So I'll walk you through engineering. This is what engineers do. They observe. So what do you see that can be better? What problems do you see? Kind of what we talked about. I like these video games, but I hate bad graphics. How can we make graphics better? Or next thing you do is think about it. Why is it like that? Does it have to be like that? But really, why is it like that? Those are the questions that you want to be asking. Those are the questions that engineers ask. And then once they ask those questions, they say, okay, how can it be changed? How should I change it? How can I make it better? Now here's the problem with better. Your better and my better are not going to be the same. But since I'm an engineer, I don't really care what your better is. It's all about me. So when you're an engineer, you get to make better that you care about, and hopefully make better that people and customers in the world cares about, but you're in control of what that better is. Next, you got to test it. You try it out, see if it works. Is it good enough? Does it do what I want it to do? Are these graphics great? Is does my computer crash less? Well, I can't fix what parts of science you don't like, but you want to understand, does it achieve the goal you want it to achieve? And if not, how do we update our plans and how do we get it right? So, I have this picture in the middle, kind of walking you through an example that I think all of us should understand about how engineering works. So when most of us were 4, 5, 6, 7 years old, our parents might have taught us how to cross the street. The very basic engineering problem. Problem one, I'm on this side of the street, I want to get to that side. So that's the problem. First thing we observe, well, how can I get across this street? Well, I got 2 legs, I can probably walk, that's a good idea. Maybe I have a scooter, maybe I can scooter across the street. But now I need to come up with a plan. What are the obstacles? What things might stop you from getting across the street cars? Loose dog, whatever. But I have to make a plan and say, okay, well, when all these cars clear, then I'll try to cross this street. Then I test it. All right, it looks clear, I start walking. But then the car turns the corner, and that's when I have to adapt my plan. I have to run them because I'm not going to make it. I don't want to get hit by cars. So again, that's a simple example. I hope we all know how to cross streets. Everybody knows how to cross streets? Raise your hand. Good. Everybody knows how to cross streets. So basically, these are, like I said, these are the things that engineers do, but it's really the things that you do. We all do them. We've been trained to do them. We just, in engineering, put some fancy words and some fancy tools around it to make it a little bit simpler. Make it a little bit more complete in our solution, but it's simply the same things we've always done. I like games. I hate graphics. Let's make better graphics. That's really it. Are the graphics good enough? Yay, make a new game. That's the world of engineering, in my mind, in a nutshell. And
all right. Hello, everyone. So, following the same model, I'm going to talk to you a little bit about myself. And then I currently work in IT, the IT department at Texas Instruments. So I'll tell you a little bit about TI and what it means from my standpoint to have a career in IT. And I think it really ties into this whole engineering concept because a lot of those same questions and thought processes that Terrell just went through really apply in this space as well. It just really depends on what area of IT you're in, you might be interested in going into. So again, a little bit about me. I grew up in Little Rock, Arkansas. So went to school and graduated from high school there. Most of my family is still there. While I was growing up, really the type of things I was doing, so I didn't have as complicated of a math problem because I don't do all that math today, but I can add and subtract pretty well. So I was kind of math and science oriented. Actually went to a high school that was I guess more of a science magnet. I was a Girl Scout, so I participated in Girl Scouts, but I just put that up there more to represent. I like to do a lot of extracurricular things too, so it wasn't all just about math and science. So one of the things that I really liked about Girl Scouts was just the opportunity to explore and learn new things, meet new people. My Girl Scout troop was a little more progressive. We didn't do the camping trips, so we took our cookie money and we went on essentially mini vacations every year. So that's how I got a lot of my travel in. Like the first time I came to Dallas and Washington, D.C. and Chicago and Atlanta, things like that. So a little bit more progressive trip, but again, just a lot of exposure to different things. Also, just participation in my church. Again, getting a lot of opportunity to do things through my church. Again, just providing me more experiences and exposure to new things and new people. And lastly, I also played sports. While I was in school, I played volleyball and basketball. So from a school standpoint, I also went to MIT for undergrad. Graduated with a degree in computer science and engineering. Once I graduated there, graduated in 2002, moved to Dallas. So that's how I came here, and I've worked for Texas Instruments for the last 14 plus years, all within the IT organization at TI. Since being at TI, I went back part-time to University of Texas at Dallas and got my master's degree in software engineering. And I'll talk to you a little bit about how that plays into the role that I have now. So my title now is business analyst. What does that mean? I don't know if I could really tell you. Essentially what that means, I'm on a software development team.
Attention everybody. Battle the Axe shirts are being sold in the cafeteria. And please remember to pick up your pep rally tickets. Yellow tickets will get you on the bus. Pep rally tickets are picked up in the cafeteria too.
Cool. Pep rally today? Yes. Got a game tonight? Is it a big game or something? Like homecoming?
Bus had to go to
Okay.
On a different campus.
That's fancy.
different campuses.
So I'm a business analyst. So I work on the software development team at TI. So my role, I'm not a developer, so I'm not the one writing the code. But I play the role of really interacting, one, with our customers to understand what their requirements are for the software that we develop. I also use my technical background to really be able to communicate with our development teams and our technical support on what type of things we need and how to translate those requirements into what they ultimately need to be coding and configuring on the systems that we have. So I wanted to talk a little bit more about IT, and I want to use the TI context since that's what I'm most familiar with. So just by, I just want somebody to shout out. How many of you have heard of Texas Instruments? All right, who knows anything about something that TI has done?
Make calculators.
We make calculators, yes. That is a good answer.
Number one answer.
Okay, not necessarily the number one answer, but that's the answer most people know, because I'm sure most of you have either owned or used or been forced to use a TI calculator, probably a graphic calculator at some point. So TI does make calculators. Our primary business is semiconductor. So we make chips that go into a lot of electronics and technology that you have today. And just because, I mean, some of you might be more tactile in terms of learning, I got some props today. So if you don't know what a chip is, this is actually a wafer that we produce. So we actually design, manufacture, test, and sell. So we have teams at TI that are designing these circuits that exist on here. These go to our factories where they get manufactured on this big thing called a wafer. They get cut out and packaged, and then they ship, and they end up in your cell phones and your wearable devices and in your computers and your cars and everything else. So if you've never seen a wafer before and what the inside of some of your electronics look like, you can feel free to pass that around. And ultimately, so one of the reasons why you don't necessarily see TI's name on end products, so we have an educational technology department, and that's where our calculators come from. And so a lot of times we end up working with other companies in order to put our products into their devices, their products. So the Samsungs of the world, potentially the Apples or the Dells or the Fords, the GMs, you know, whoever, we're working with those companies. So although you might not see TI's name branded on some of those things, ultimately we're inside those technologies and making them work. I had another demo. Unfortunately, we can't get it to work, but I mean, how many know what this is? It's a basketball. Well, this is a special basketball. It's a smart sensor, so it's a smart basketball. So there's chips and things in there. There's sensors in here that can essentially via Bluetooth connect to an app on your phone and provide you information and data about your basketball skills. So, you know, if you're good, you might be able to prove that you're good, I guess. If you're not, this might show it. So unfortunately I can't get it to connect to my phone, so we can't demo it today, but trust that it is, I'm assuming it's in there. And it's working. But again, that's an example of ultimately an end product, but TI is in that product and ultimately making it work. And hopefully we're not the ones that's causing it not to work right now. So that's what TI does. Let's talk about IT a little bit. So in order to get this done, if you think about any company that's out there, again, we named off some, even like the Amazons, the Googles, the Nikes, the whomever, so you see the end product, there's a lot that goes on behind the scenes in order to make that stuff happen. And so that's the way I think a lot about IT. So even if we have companies out there that whose end product is IT solutions like Microsoft and things like that, but every company that's out there has IT associated with it. So in the case of TI, our IT might be broken down into these different areas. So we design chips. So we have R&D, we have research and design teams out there that are developing what this next big device needs to be based on what they're hearing from our customers. So we have a division of IT called design or engineering IT. That's actually the area that I work in now. Our primary responsibility is to provide solutions databases, information repository software that supports what those designers are doing in order to design chips. And that can be everything from how do we handle the large amounts of data that they're producing to providing software so that they can collaborate externally with the company to security and making sure that what they're creating, that intellectual property is protected and is not going to be, infiltrated or stolen by someone that shouldn't have eyes on it. You have the manufacturing piece. So one of the cool things, so I actually work at the, I don't know if any of you venture out of or live outside of Louisville. So off of 190 George Bush, we have a TI site called our Richardson Fab. And that's one of our factories where we produce those wafers. So if you actually go into the factory, you'll actually see, essentially, it's synonymous to the autonomous cars moving around in the factory. So that's an automated factory where it's picking up and moving those wafers around and dropping them off at the next step in the process where these are getting manufactured. Very little human interaction. So a lot of software automation, a lot of data being driven, a lot of testing happening around those, and even from a hardware standpoint, the computers and other things that need to be in the factories in order for those wafers to get produced and ultimately out the door. A lot of that comes out of our manufacturing IT. One of the last pieces, we got to sell them, right? Otherwise, we don't make any money. So we have salespeople around the world for Texas Instruments, and they all need some type of support from an IT standpoint, whether that's sell software so they can keep track of who their customers are. Because we have a salesperson that's working out in California and Silicon Valley. They want to make sure they keep track of everybody that we're working with out there, so they know who they're calling, who they're working with, what they're buying, all of that good stuff. Lastly, people like me, I work at TI, I would like a paycheck.
No, sir.
I would like to see something coming out of the hard work that I'm doing. So we also have IT systems that manage our people resources, the people that work at TI, to make sure that when Jeanette goes and looks at my bank account, that my check has been deposited and I can go shopping that week for my family and all that stuff. So there are IT systems out there that manage that. And lastly, for those that like computers and more kind of, getting more tangible with things, we have more our infrastructure area, which is an area where I started in TI, that handles a lot of our major servers, networking, things like that. Actually, here in Louisville, TI has one of our biggest data centers that houses a good portion of our data that really allows the company to run. And there's people that need to manage that, make sure things stay up. Even if you think about companies like Google or Amazon, those are companies that have to stay up 24/7. So you need people that are working to keep those systems up, that know how to make sure that things are robust, that they're highly available, meaning that if something goes down over here, there's redundancy, so that you don't lose out on systems and then Google goes down, for 4 hours. So that would just be like a catastrophe, basically. So that's just a sense of different areas you can go into. And this is just kind of a splatter example of roles in IT. So I started out at TI as a Unix systems administrator. And again, that was more from that infrastructure standpoint, supporting certain customers within the company and making sure that their infrastructure and operations were robust. I've actually supported email for TI, which was to me pretty cool, because again, you got to learn a lot about networking. That's where I started to learn more about security. And things like that. I've also worked more moving into the engineering IT and just software development spaces, whether that's as a business analyst, my title now. I also do some work more as a solutions architect, where I'm really working with our customers and our technical teams to really come up with either current solutions or what our future strategy is going to be for certain applications. I do want to point out, for those that are interested in computers, even if you use a cell phone, use a computer, tablets, and things like that, cybersecurity is, if you're interested in IT, that is a big deal. All of you, I'm sure, have heard something about phones getting hacked, things like that, these major corporations getting all this data stolen from them. Having awareness and even training skill sets in cybersecurity are going to always be key, because as long as people continue to find ways to break into our systems, we need people who know how to do that, but because they know how to do that, they also can figure out ways to either slow it down or prevent things like that from happening. And that's big from a career and a company standpoint, because when that happens to a company, that's money. That's money out the door for companies, and they don't want to lose that. So now that we've talked a little bit about engineering careers and IT careers, what are some of the skill sets and things that we just sort of think that you need to be thinking about as you're here? What's the grade? This is 9th and 10th grade. So you're starting to think maybe about colleges or what's next and all that, and get some head nods. Yeah, is everyone thinking about or planning to go to college after high school graduation? Okay. All right. So one of the first pieces, and I mean, I don't know how many talks you've been to around engineering, IT careers, and things like that. No, that was intentional. Yeah, you're okay. I mean, one of the obvious things is the technical knowledge. So wherever you are right now, whatever math and science courses that you have the opportunity to take, definitely take advantage of those opportunities. And I don't care if it's regular, if it's honors, if it's AP courses, community college, you have the opportunity, definitely encourage you to take advantage of those courses. So, because that's going to be the knowledge upon which you're making decisions going forward. Again, back to the problem that Terrell walked you through earlier. I mean, there's some decision things that you have to make, but a lot of that is just founded upon what information do you have about that scenario in order to be able to think about it critically and rationally. So definitely doing that. Things like this where hopefully you're learning something, and just opportunities to participate and actually get your hands dirty. So not only just listening to your teacher and learning, but how can I extend this further and apply what I'm learning in different things. So whether you have, student organizations around science or math and things like that, that's definitely something to take advantage of. Shadow and engineer, I know what that means, but that's really about just finding ways to learn about what does it look like in the real world. Yeah, it could be internships, and I don't know at this level if you have opportunities to do that. Like Allie mentioned, this past summer, we brought a group from the school over to the CI. Every year we have an event called Take Our Daughters and Sons to Work Day, where a lot of TI employees will bring their children or kids that they know, but we also take the opportunity to invite just groups from the community to come and experience that as well. And that's one way, again, just to be able to get insight on, I'm learning all this in school, but what does this really look like if I want to take this past, high school and college? What am I going to be doing on a daily basis? And higher education, can't speak too much about that. Obviously, Terrell and I have been fortunate enough to be able to pursue higher education. I've gotten my master's degree. Terrell just finished up his PhD. And so it's definitely possible. It's really just a matter of thinking about now, what is it that you want, and just being aware of what it takes to get there. It's not easy, but it's definitely something that's doable, and it's a goal that you set for yourself. So those are some of the more concrete skills. The other thing I will add to that is coding skills. I don't know I'm assuming you may have some computer science or programming courses that you have the opportunity to take, or if you're already dabbling at home, if you have access, there's plenty of websites. Our 6-year-old, soon to be 7, is doing summer courses and after school already, where he's learning about coding and at least how to put together things into a flow in order to make things work. So even at that age, and just because everything today is just so powered by software and what's going on. So even if you ultimately don't end up in this space, having an awareness of how it works is definitely going to be key. And I don't think that's going away anytime soon. The other piece of this that we really want to focus on a little bit is outside of those kind of technical skills. I mean, what are, I guess we from a corporate standpoint would call them more soft skills. If you have the technical knowledge, I mean, that's great. But a lot of times if you don't have the ability to interact with other people or to be able to explain what it is you know, I mean, sometimes it could be all for nothing, or it could seem that way, because it's great to have ideas in your head, but if you can't get them out, that's another thing altogether. A few different ways you can get that experience is through here at school, student organizations that you're involved in, sporting teams, so football, basketball, you know, whatever that is. If you have volunteer activities, leadership roles, that's something that's key, because again, you get a chance to interact with different types of people, different personalities, and you just understand how to come into different situations and how to handle those things. And even, you know, part-time jobs, again, you know, if you work a register, like I worked at Hobby Lobby when I was in high school, I was a cashier, I used to stock shelves a little bit, I love working at Hobby Lobby, they close at 8 o'clock and I open on Sundays, awesome hours. I think it's the best high school part-time job ever, just so you know. So go apply if you're looking for something. But again, just even at the register, just having to interact with people, whether it's, you know, elderly or younger people or people that have no clue how to find, you know, these, you know, fake roses that they're looking for. Just again, being able to converse with people and communicate helps a lot. It helps you to build different skills. There's teamwork, presentation skills are key, so that one day you're up here doing something like this for the next generation of folks. Being able to listen and observe, that's a key skill that we talked about earlier in terms of engineering. Conflict resolution, empathy is an interesting one, because again, that's just part of your ability to relate to other people and understand other people, whether or not you agree with what they're saying. But again, if you're in a field of engineering or IT where a lot of what you are doing is for other people, you have to be able to understand where they're coming from and what their needs are, so you can provide a solution that works for them. And again, I think, you know, work ethic, this field and science in general, if you've done projects, I mean, we talk about fail, first attempt in learning, I mean, all of that good stuff. You just have to know how to continue to push yourself for what it is you're trying to get to, especially in engineering fields where you're trying to do something to improve and make better. It's not always going to work out the first time around, so you have to know how to continue to persevere and work through what it is you're trying to do. Ultimately, I think it's about being a thinker, being critical, having critical thinking skills, being creative, asking why questions. Now, I will tell you, some people don't like that when you ask why. Your teachers may not like that, but I think we're going to encourage you to do that anyway, because asking why is important for you to be able to understand what it is you're doing. And if you're not understanding what you're doing, you can't guarantee that what you ultimately produce is the right thing to produce. So you got to ask questions and make sure you understand what's going on. Challenge the status quo. If you don't like how something is, back to where we started. You know, if you use computers but it's crashing all the time, or if you're, you know, playing football and tired of getting injured or whatever, I mean, how can you fix it? How can you change things? You have the capacity to be able to come up with ideas and do things differently. Find out how things work, and lastly, just be curious. You know, coming here, I appreciate you all signing up for this and just learning about something else, because you have the information now, so you may walk out of here today and say, yes, engineering sounds great, or IT sounds great, or TI sounds cool, I want to learn more about that. Or you may walk out of here and say, you know what, maybe not, maybe I want to go over this way instead, and that's okay. The important thing is that you're out there looking and searching and trying to get that information, and you're really making decisions based off of good processing and thought process around that information. So that being said, that's the end of our presentation. And so now we want to open it up to any questions that you may have about any of these topics, about us, or anything like that.
What are the differences between the IT degrees and which one you're going to go into college?
what are IT degrees?
Well, so
Are there
let's
IT
talk
degrees?
about that. Is there any particular thing that you're interested in right now?
Mostly programming, just like
Yeah.
all around, even programming skills.
So I will tell you, there's a lot of schools, you'll see degrees in like information systems, computer systems and things like that, computer science. I think any of those could be good. I mean, personally, I'm partial, even if you ultimately go into IT, if you're into programming, an engineering degree or computer science, software engineering, I think engineering, if there's an engineering component, I think it teaches you a lot about the thought processes and how to think critically and how to go about really delving into a problem and figuring out what the right solution is. On top of just learning kind of the technical skills, the coding, the Java, the Python, the whatever. So, I don't know if you have anything to add on that.
I agree. I mean, the primary concept is you said, you asked a very specific question. What should you go into? I don't know, because I don't know you. You know you, so you need to figure out what you like. But to Jeanette's point earlier, understand what those things look like. So like you said, there's information systems, there's computer science. If you like coding, like I know a really smart guy, he graduated from UTD, was an undergrad, he's doing really well now. He really loved coding. And when he finished his computer science degree, he said, why did they teach me all the other crap? I just want to code. So I'm like, because you need to understand it. But he's like, I just want to code.
Yeah.
So you really have to understand what those schools, when you're looking at the schools, you're looking at the programs, what is their focus? Is their focus on you being some theoretical computer scientist that makes new algorithms that nobody cares about for 50 years? Or is their focus on you being the best programmer you can be so that you can be awesome in programming? Everybody has slightly different focuses, so you need to kind of be careful in what you pick from that perspective. But for everybody, just in general, I'll throw in my bias. No matter what you want to do, especially if you don't know what you want to do, I don't think you can hurt yourself by being an engineer, maybe being engineers. I know engineers that are lawyers. I know engineers that are doctors. I know engineers that pretty much every field. I know engineers that are politicians, which is kind of odd. They're like the only one. But anything that you want to do, engineering will give you the preparation and background to just slide there without too much work. Now, if you want to be a doctor, you might have to take a few more biologies, but that's okay. That's your choice.
The other thing I will add, if you ever look at like information systems types of majors, and again, you have to look at the school, a lot of those are actually in more the business side of things at some schools, which there probably will be some programming classes, but you're also going to get it more from a business or a management standpoint as well, which might mean more how to manage large systems and things like that versus really being in the coding. So again, it really takes looking at the school and the particular program, but I would definitely encourage you to look at, computer science, software engineering.
About like networking systems and just being able to have enough experience and knowledge in that to like maybe write my own code.
Yeah, definitely. We have some giveaways for folks that ask questions and things, so I'm going to give them a question later. I don't know if you want to, I mean earlier, sorry. It's opposite day, so I don't know if you want anything.
So how we need, is there like background knowledge we need to enter the training program at college? Or do they teach you everything you need to know?
That's a great question. So for those that couldn't hear him, he said the background knowledge you need to enter an engineering program in college. Do they teach you everything you know? Again, I'll say that's highly dependent on the school, but I will say there's an expectation of knowledge. So most programs that I've seen, they expect you to have a concept of advanced maths, like pre-calc. Some people will for you to know calculus to some extent, the sciences and things of that sort. So you want to make sure that, like Jeanette mentioned earlier, you take as many challenges as your capacity can handle. So I know some kids that have taken like a ton of AP classes. And it's like, that's great, except that why did you take them? Well, because they said I should take AP classes. No, you shouldn't take AP classes just because they're offered. Now, if you like math a lot and you want to take AP calculus, go for it. If you hate math, don't take AP calculus because you're going to hate half your senior year. It's good to do if you want to do it, but don't just do it because you think you should do it because then you do bad in classes, which doesn't help anybody. You don't learn the best. You can't when you don't like what you're doing. Some stuff you have to do, but in general, for engineering, they're gonna expect that you have a strong math background. They're gonna expect that you have some concept of science background. But they will offer the classes that can catch you up if you feel like you're behind.
We had a question of.
What do you recommend for specialty for bio?
Bioengineering, biology. Go with the easy answer.
I mean, I think it's still definitely math and science. It's funny, when I was at MIT, I ended up majoring in computer science, but I actually we had undergraduate research opportunities, and it was with a mechanical engineering professor that did biomedical engineering. And a lot of things that I was doing was still computer science. So it was development, it was building systems and things like that, but it also tapped into my more natural sciences, I guess you would call it, skills, so biology, chemistry, and I don't know how many advanced courses you have in those areas.
And that still goes if I was not interested in like hobby.
Look like what?
Hobby.
What is awesome.
Oh, you mean like prosthetics?
Yeah.
Fair enough. Oh, now you just walked back into a world I know.
Yeah, there you go.
So yeah, so from that perspective, if you're looking at prosthetics or specifically, so for those that don't know, if you're not aware, he did this. That's kind of how I figured out what he meant. So a prosthetic or augment is basically something where you design something that goes in place of maybe a lost body part. So somebody lost a leg, or somebody lost a hand, and you want to replace that. So that's going to be, there's a biology component there, but a strong component there will actually be in mechanical or in electrical engineering, specifically robotics or controls, mechatronics. If you want to write down all the fancy words, controls, robotics, mechatronics. And the idea there is that you need the biological understanding because this is going to attach to somebody's body, right? So you want to be thinking about, is it comfortable? Because if you haven't lost a limb, it can be tough to understand how difficult it is to put on a fake hand. But so you want to have that empathy that we talked about earlier, but again, mechanical engineers do a lot of that. Biology informs that. Electrical engineers and a lot of controls work to be able to make sure that hand does what you want it to do, when it should do it, or that leg does what you want it to do. And if we have time after, I can use my numbers because I can connect you with some people that specialize in that.
Okay.
And they'll give you everything you want. Wait, I'm sorry, I'll go there first.
So what steps do you take from transitioning from high school to engineering? What steps y'all have to do in high school, like, start your engineering career?
I just went to school. that's really, I mean, I wish it was harder. I wish it was, I mean, so like you talked against.
Are the engineering programs at a college competitive? So do you register as an engineering major and get in?
So that varies from school to school. That's a great question. So, and I'll tie that into your question. So some schools, you get accepted to the school, and then you have to get accepted into the engineering program separately. Other schools, you get accepted into the school, you can go into whatever program you want. But basically, if you have those math science skills, you want the scores to be strong in your testing, everybody looks at that, and you've taken advantage of the opportunities you have, then you just go to the university of your choosing, and once you're there, you'll figure out pretty quickly what you need to do, because everywhere is different than everybody is.
Okay, so each engineering, like civil, and all of them have different years of learning, or is it all the same years?
Most degrees are still going to be 4-year degrees. Put that in quotes because a lot of people don't finish in 4 years. But most degrees of all sorts are still going to be targeted to be 4 years. You'll just have different focuses when you start. And you can ask that question before you walk out the door.
I was just wondering, is it pretty much the same thing for the augments and the prosthetics? Would it for mechanical engineering? The same studies pretty much?
It's the segment. You would have to focus towards controls, but yeah.
Will you guys take the bus to Maine?
Thank you, guys.
Thank you.
Thank you.
I can, if you wanted to have more information, there's a professor at UT Dallas.
I'll do pass to
You can give it to her, and then I'll get it, and then.
You are Evan.
Okay.
But yeah, I
Sorry.
can,
I'll
send you
connect
the
guys.
information and then he can tell you all about that, cause that's what it's like.
Okay.
Yes.
Oh, no problem, no problem. Any other
Yes, good.
questions or anything?
I don't know nothing from Jill.
She's an expert.
No, not really. It probably just depends on what you focus on. A lot of schools, and you have different tracks. You can go down. For example, when I did my master's at UTD, it was in computer science. It was a major or a track in software engineering. You could also do like a security track where you learn more about that space, or more of the systems track where, again, it's more larger scale. It's not as much coding necessarily. So it really just depends on whatever school you look at. You know, kind of they'll have sort of tracks you can go down, or you could a lot of times just mix it all.
Who wants to choose
I'm just throwing them away.
Yeah,
And use the
I'll add
outside
that, I think.
Okay.
From high school, do you get scholarship or anything?
Yes,
Yeah, there is.
yes,
I mean, there's so much. Well,
yes.
yeah. The answer to that is yes. Yeah. I mean, depending on what school you're going to, they may offer scholarships. There's also different organizations and things in the community that offer scholarships. I'm trying to think of something that's engineering specific.
And I mean, while she's thinking of that, I'll add that there's even, there are programs specifically for underrepresented minorities in engineering fields,
Yeah.
which can help